Okay, so just to give you a little background, we have Dr. Cindy Atman. Okay, she is at the University of Washington. And just let me take 2 minutes to read out her background. She's the founding director of the Center for Engineering, Learning and Teaching, CELT. By the way, Cindy, we have our recent initiative is to start centers for teaching and learning at all our 50 colleges. So many of them have now been trying to get their act together.
Great.
So Cindy is a professor in human-centered design and engineering and the inaugural holder of the Mitchell T. and Lela Blanche Bowie Endowed Chair at the University of Washington. Dr. Atman is co-director of the consortium to promote reflection in engineering education, funded by the Leona M. and Harry B. Hemsley Charitable Trust. She was director of the NSF-funded Center for Advancement of Engineering Education, a national research center that was funded from 2003 to 2010. Her research focuses on engineering design learning, considering context engineering design, and the use of reflection to support learning. She is a fellow of the American Association for Advancement of Science and the ASWE. She also did a PhD degree in engineering and public policy from Carnegie Mellon University. So excellent, outstanding. Thank you for joining us, everybody. And thank you, Cindy, for getting up so early in the morning with your team, which includes Ailey Zhang and Juliana Flores, okay? And so over to you, Cindy.
Great, thank you so much for that introduction. And let me share my screen here. And get my chat box set up. All right, so today, welcome. Today we are going to be talking about considering design, this massive topic that we think about in engineering. And we're going to be engaging in some research-based teaching activities. You can see what's behind me. I thought I would also show you a picture of once I get my cursor working here of what's in front of me. But first I want to introduce my team. Along with me actually is my amazing research team, Juliana Flores. I am going to stop share so we can see actually in the gallery. Juliana can say hi. Both Juliana and Eileen are students in human-centered design and engineering here, and Juliana is a graduate student. She's going to have her cameras on and off because she's having Wi-Fi issues this morning, and so you'll see her on and off. And then also Eileen Zhang, who is an undergrad student who's doing research with my team, and we will be collectively engaging and putting on this experience for you. Okay, back to share screen so you can see. As I was preparing yesterday, I usually have a 2-screen setup, but I really wanted to see the chat box. So I borrowed my husband's screen to put the one in the middle here. So if I'm looking this way, I'm trying to keep up with what's going on in chat. And as I was doing that, I was just recognizing that this kind of split brain work that we do as teachers is what we're just always used to, right? Like we're trying to deliver content, but we're trying to see how it lands with students and how is this group working, and then how's the mood of the room and how things are going, and do we need to take a break? And so our brains are just split all the time in this modern world. And as we are, as previously mentioned, trying to wake up over here with our split brains at 6 a.m., I want to recognize that so many of you have had an entire day of work, and your split brain is already tired and it's dinner time. And so we already have 76 people who are signed up. And so I just want to say thank you for actually spending your dinner time thinking about design for the next hour and a half. And if we have split brains trying to wake up on one side of the world and tired split brains who would rather be at dinner at the other side of the world, thinking about design, somehow magic is going to happen. So thank you for coming. Speaking of like where and time, what we'd like you to do is, once I can get my cursor to work, we'll work on that.
And
Is in the,
can you go into full screen mode, or do you prefer this mode?
no, I like this
You
mode so
prefer
I
this
can.
mode? That's fine. That's fine. Yeah, that's fine. Keep
I'm
going.
all about context, and if I don't see what's ahead of me, then I'm done. All right, so if you could please, in the chat, jot down the country you're from and the, so where you're from and when you're from. So the country you're from and what time it is for you, so we can see who we're talking with today. Oh, in Malaysia, it's 9 o'clock already. In Portugal, India, 6:30. A lot of people from India, Bangalore as well, Poland and Switzerland. So late afternoon there. You're having your tea. Perth, yeah, I know Perth. That's where my husband is from. So really late for people. And then some others from the US. In Kenya, it's late afternoon, Colombia, India. So, wow, this is really an amazing set of people from all across the globe, all of us interested in engineering education and design. And that's really rewarding to actually be with you. I actually might be meeting some of you for a second time. I had the honor of seeing what Krishna is doing with the IUCE schools when I came to India with his group in 2018, and it's just amazing things. And I've also had the pleasure of giving presentations with many of the organizations over the years, the IFES organization, and visited Malaysia. So perhaps I'm saying hello to a couple of you for the second time. And here we go. So we know where we're from: Colombia, Yucatan, Mexico, a lot more from India. Oh, Kyria, hello. How are you? We need to catch up for sure. And we will just use this instead of the cursor. So now that we know where we're from, we'd also like to find out, what are the courses that you're currently teaching? So if you could drop in the chat the courses that you are currently teaching, that would be great. Okay. Forensic accounting, bioprocess, wireless communication, English language, consumer behavior, linear applications, algorithm analysis and design, higher ed, signal systems, heat transfer, first year engineering, innovation and design thinking, antennas, soft computing techniques, bioseparations, English language, strength and materials, sewer systems, digital communication, leadership, design thinking for social innovation, transformation of higher ed, how to teach, design of wasteful management systems, solar energy, oh my gosh, Python programming. So not only are we a diverse global community in terms of where we are in the globe, but we're really turbo machines, goals in engineering education. We're also a great diverse community in terms of what we're teaching. So here we go. Our learning objectives for today, we are, there we go. Engaging with 3 activities we've used successfully with students, and you saw in the abstract the learning objectives of, by the end, being of describing the broad nature of design, process models, expert design behaviors, and thinking through how you might use some of these activities in your teaching. And just to remind everybody, all the materials will be on Canvas, and we'd love to have you grab them and adapt them to your particular context. To set the stage, I've been engaging in research on design processes for a couple of decades now. And the reason why I chose to dedicate my life to this is because I really wanted to explore how to teach engineering students to think about the impact of technology on the globe, to consider context in their engineering work, and to really minimize unintended consequences. We need to be teaching our engineering students to think broadly. And if you want to teach engineering students, it's really helpful to have a definition of engineering. The one that I've always resonated with is Bill Wolf's definition, which is elegantly simple, which is that engineering is design under constraint. Just a totally elegant way of describing engineering. And Bill, he was the past president of the National Academy of Engineering. And he went on to describe engineering as design under constraint, where the constraints are what differentiates different engineering problems we're solving. We're constrained by nature, by safety concerns, environmental concerns, by whatever budget we have, and all the ilities that he called reliability, constructability, maintainability. But he really emphasized that engineering is creative, and it's really designing what can be. It's seeing possibilities. And just a quick pause for a moment. When I used this definition with students, we gave a workshop this past fall, and it is really quite an aha moment for students even to hear this definition of engineering. One mechanical engineering student said, when people ask me about my major, I never had a good definition of engineering before, but now I can tell people engineering is design under constraint. So something to tuck away for when you're talking with students about what is it that we are actually engaged in. So back to setting the stage for my research goal. If my goal was to teach engineering students to think broadly and consider context, and with that, the definition of engineering is design under constraint, how would I then do the teaching through to consider context? And that is as engineers engage in design. Engaging in design is how engineers get engineering out into the world. And the artifacts and systems that we design as engineers outlast us, and their impact on the world outlasts us. So that's why we really need to think broadly when we're actually doing the design in the first place. So I embarked on a research program to understand how engineers do design. I'll be describing that research later on in the talk today, in the webinar today. So that's the research on design expertise. And I'm having my waking up at 6 in the morning voice. So I'll be taking sips of water throughout, I believe. So we did research on design expertise, and then we have more recently been developing teaching materials. And so what we're doing today is focusing on a couple of activities that we have engaged with in classrooms and workshops. And at the end of the talk, I'll talk about a new app that we've developed and our website where we have these resources if you're interested. Where might some of these activities land in some of the courses that you're teaching? Well, design teaching has a really broad landscape in engineering education. We teach capstone design. We've done that for a long time. A lot of places are now also teaching first year or cornerstone design. Some institutions have a design spine throughout the curriculum. Lots of classes have design projects in them. We have maker spaces and service learning. So there are a lot of places where we can be teaching the concepts of design to our engineering students. But as we know, as design teachers, it can be a huge challenge to teach. Why? There's so many definitions of design. We use the word so many different ways. It's a noun, it's a verb, it's an adjective. It's what we call a final product or a sketch of an idea, but it's also the act of engaging in an act of creation. It's an important component of engineering, but it's an important component of many professions. It's the name of an entire profession. There's a recent emphasis on something called design thinking, and this can be a hugely confusing landscape for all of us to navigate. It can help to actually bring this kind of difficulty to define into focus by getting a bit more specific. If design is a human endeavor, who designs? Well, Herb Simon, who was a pioneer and helped found the fields of cognitive science and a pioneer in computer science, Herb Simon says everyone designs. And it's everyone designs who devises courses of action aimed at changing existing situations into preferred ones. So going from state A to state B, where A is some problem or some need with constraints like we've talked about, like Bill Wolf talked about, and B is one of many possible solutions, not just one. Design, I differentiate design with problem solving, where problem solving is you have a state A and there's only one answer B. But in design, there's myriad answers B that could actually satisfy the constraints. And that's one of the things that makes it so difficult to actually engage in. So with this definition, who designs? Well, engineers design, of course, but architects and authors and musicians and choreographers and chefs and basically all of us, and basically much of the time. When we're engaging in design, when we're engaging in design thinking, what we're doing is enacting a process with a mindset. And the process that we are enacting, lots of people, as we were saying, have lots of different definitions for design, but most of them include these kinds of activities. We're understanding the problem. This can be called empathizing, gathering information, defining the problem. Once we understand the problem, we're generating ideas to solve the problem. So this can include brainstorming and ideating. Then we try out some of the ideas that we've generated. We model them, we prototype, we test them out. We choose an idea and make it happen. So we're deciding, we're implementing, we're producing. And then we hopefully determine how it worked. So we assess, we reflect, and then repeat. So when we're engaging in design thinking, we're enacting a process, but we're not just enacting the process, we're enacting the process, we hope, with a nimble, broadly scoped mindset. What do I mean by that? By that, I mean that we're flexible. At some points in the process, we're diverging and sometimes we're converging. We're going back and forth between analysis and synthesis. We're going back and forth between understanding the problem and generating solutions. So we're flexibly going across these kinds of states. We're reflective and engaging in what we're calling design awareness, meaning we are aware of what we're doing, where we are in a design process. So we're making informed decisions of what activity we're going to engage in next and reflecting. We're seeing through the full cycle from identifying need all the way through implementation and seeing what the problems with implementation are. We're not just brainstorming ideas and then walking away. We're seeing through the full cycle. We're being human-centered, and that's with all stakeholders, not just users, but with everybody involved in the process of making whatever solution we're making. And then finally, getting back to why I've been doing this work in the first place, it's taking a broad perspective, understanding many perspectives that are around the table and understanding the context of the situation. So engaging in design thinking is enacting a process with a nimble mindset. So let's work through an example. So a common example, what's for dinner? Apologies to those of you who are here instead of dinner. I hope we're not making you more hungry here. But let's say my family was home. I want to figure out what we're going to have for dinner tonight. So we need to understand the problem. How many are going to be around the table tonight? What raw materials do we have? What leftovers in the fridge, staples and spices in the pantry? What constraints do we have? How much time? Any helping hands? And then generate ideas to solve the problem. We could make stir fry with what we have on hand. We could order out again, try out some of the ideas, run them by the family. What do we want to do? Choose one and make it happen. And then determine how it worked. The photographs on the side of the screen here are all ones when my kids were home helping cook. I am not a cook at all, so it would determine how it worked. It works great when my kids are doing the cooking. When I'm doing it, it's more likely to be, where are we ordering out again? Cooking, not my strength. But the point here is that trying to figure out what we're going to feed the family for dinner, I went through a design process, and it's the exact same basic design process that we engage in when we're solving engineering design problems. Our challenge as teachers of design, so what's our situation? With the concept of design as being abstract, having many meanings, and being difficult to teach, well, we have definitions of design, we have descriptions of design process. Why don't we just tell them to the students and then that's it, right? But simply telling students the definitions or showing them the process is not sufficient. As we know from our esteemed colleagues, Rebecca Brent and Rich Felder, active learning is actually what we need to be doing. And particularly when teaching a process like design, doing it actively is absolutely essential. If you haven't seen the first webinar in this series that, that Rebecca and Rich did, you really need to. So when I'm designing these activities to teach design, teaching it actively, I turn to research on learning to help me develop these activities. And the learning research principles that I have always resonated with, I summarize here on this slide. And I'll go through them here. And that is, learners come to a situation with a full life already, and you need to honor that. Prior conceptions matter, pathways matter. Knowledge organization and integration are essential to learning. And both the concepts and the links matter when you're actually building up your neural network. When you forget something, the concept isn't what disappears in your brain. The link to the concept is what disappears. And so strengthening the link is what's super important when you're developing a neural network. Learning happens in the learner, not the teacher. Sort of a hard thing for a teacher like me to understand, but learning can only happen if the student is doing it themselves. That means that the motivation to learn is matter. And I found that making learning personal for students is one way to really increase motivation. Learners should be active, not passive. So practicing retrieval from the neural net and applying it to some new situation. I love the statement, neurons that fire together, wire together. If our goal is for students to transfer information with the goal, transfer a knowledge or a skill from the context that they're learning it in to a new context, one way that I've found to do that is invite students to think forward of themselves as some sort of practitioner in the future. And then thinking about thinking is important. And reflection and metacognition are really important. So applying those principles to developing teaching activities in design, we've developed a set of activities that honor students' past experiences as designers, invite a lived experience through active participation. So reconcretizing these abstract models that students engage with, that we teach our students with. Actively helping students make links across concepts to build their neural networks and strengthen the links. Are exciting to engage with, we hope, and hence motivational. Invite students to think forward of themselves as future designers. And we make space for students to be reflective about their design processes. So today, we're going to invite you to participate in 3 of the activities that we designed with these findings in mind. What counts as design, many models of design processes, and what are expert design behaviors. And there are more activities that we will talk about at the very end of the webinar on our website called Design Signatures, if you go to the Dear Design tab. So, take a breath. We've already talked about considering design and engineering teaching, and we're going to now dive into the first activity, which we're calling What Counts as Design. To explain the background colors for the screens, the activities that we're engaging in today have colored backgrounds. The blue ones are us as educators, speaking to each other as educators. And the ones with the green backgrounds are activities we've used with our students. And these are the ones that you can pick up and possibly use with your students. But we're going to be engaging with ourselves today as educators because we're all always students, right? So with this first activity, the motivation for the activity, if we want to provide students with a lived experience from the process side of things to understand that design is also a common activity that they engage with in every day, it also provides them with a lived experience from a nimble mindset to be able to use everyday design as a metaphor for their engineering work. They can bring everyday life knowledge into their engineering design work, and it could potentially help them get unstuck if they get stuck when they're solving a design problem. And it can help them feel more comfortable as designers and increase confidence. So here we go. We're going to be asking you to write your responses in chat. And if you can, Try not to look at other people's responses in the chat until you submit your own. We're going to give you a minute and a half to engage in this activity. And so I'll be silent for a minute and a half and start to read the chat at a minute and a half. So if you want to actually wait until that point to post, that's fine, but write your responses in chat, trying not to look if that works for you. So here's the question. In the chat, I'd like you to individually brainstorm a list of activities that you consider to be design and cast a broad brush. So include your engineering examples like integrated circuits and transportation infrastructure and deploying a sensor array for environmental measurements, but also include things like making dinner. So, and we will start the minute and a half now. Okay, 20 seconds left. All right, so if you haven't posted yet, go ahead and post. And I was jotting down things as we saw. So designing a smart cradle, an iChip, a bike, planning a trip, making pretty cupcakes, figuring out a transportation plan, a homemade water filter, team roles in a research project. A lot of people said planning our course. Absolutely. When we're figuring out how we're teaching, we are engaging in design activities all the time. Making a city more livable. Art, making a dress, making a bike, making a plan, planning an event, making a wallet. Some people had software, planning a short film shoot. Yeah, the design that would go into that is just huge. Designing microwave filters. So fabulous responses to this activity. And that's exactly what we get when we actually engage with students with this with this task. So here we have some student responses from a couple of times that we've used it. So we see things like product design and website design, but also planning how to find a job and doing cooking and helping to do interior design. Somebody had interior design as theirs, have interior design remodel for my parents. Here is another class where students are saying drawing and decorating and writing and architecture and furniture making. And so really conceptualizing design is much, much bigger than engineering, and students are sort of like, whoa, that's really interesting. Some student reflections from past engagements with this design. Sketch things such as design is at the intersection of thinking, living, making, and doing. Design permeates everywhere. It really cemented the concept that design exists everywhere, and it's not just embodied by formal or professional work. So these kinds of aha moments can be really helpful for students to understand that that they're engaging in design all the time, and then they can bring that into their engineering world. Different variations that we have used with this particular exercise. If we're in person, we give people sticky notes, and they then do affinity grouping while they put the sticky notes on a whiteboard or the wall. And of course, when we all pivoted to online during the pandemic, we were doing this exercise in Miro boards, and students have the same kinds of insights and aha moments, no matter what kind of variation we use. So that was the first one, pretty quick, what counts as design. The next one is a little bit more involved in the actual exercise, and this is the one we're really crossing our fingers for. And that's the one that we're calling many models of design processes. And in the many models of design processes, we all know as engineers, a model is a representation of what's happening. And in this case, it's the design thinking activities that we already went over at the beginning of the talk here. So typical components, understanding the problem, generating ideas, etc. And there are so many different variations on how you can build this representation. And each of the different kinds of representations provide different affordances for people who are using the model. And so we'll go over some typical kinds of models here. On the left, here we have box and arrow kinds of models. Where the activities are in nodes or boxes, and then the arrows are intended to show that there's iteration that's important. The one on the left is one that we have in human-centered design and engineering: research, ideate, prototype, evaluate, produce. The one on the right, those of you who are mechanical engineers might recognize the classic Paul and Beets engineering design process model. Those of you who might be collaborating with Bill Oakes from Purdue in the EPICS program would identify with the EPICS design model, which really conveys the iterative nature, not across the whole model, but the fact that you also iterate within each one of the activities, and that the whole thing can really be a circle. Another model people might be familiar with is the design thinking process model from Stanford, the hexagons on the right-hand side, and the design thinking model from the Nielsen-Norman group, which take the same activities, but really show iteration by showing it in a circle form, showing that the fact that you really go through the cycle multiple times. Another very different variation of a model of design is the double diamond model that you may have heard of. And this came from the British Design Council. And it is really to convey that when you're first understanding the problem and then you're developing and pulling together a solution, the first is in the understanding, you want to be diverging, discovering what is in the problem, asking all kinds of questions, and then converging to an understanding of what the problem is that you're solving. And then diverging again to figure out what kinds of solutions might be interesting, and then converging again to choose some sort of solution to develop. A famous statistician, George Box, very famously said, "All models are wrong, some are useful." And if we apply this to engineering, I think that we can certainly relate to that. And in the case of design models, we are really cognizant of the fact that some of these models provide affordances like converge, diverge, and some provide affordances to see iteration. And so that means that the models would be useful at different times in the design process. So if we want to teach our students, if we want to provide our students with a lived experience, to really experience that from a process perspective, there are many models that have different emphases. There's not just one model of design. It can be really easy for students to take one model of design process and then use it as a recipe, just going from 1, 2, 3 through a model. And so this is to provide a real example that there are many more than just one model. And from a nimble mindset perspective, help students see that they don't need to be constrained by the rigidity of one model. Having many tools in the toolbox can help them get unstuck, and that can increase their comfort as designers and really increase confidence. So the tool that we use is the Dubberly Compendium of Design Models. This was a compendium of models that was put together by an architect, Hugh Dubberly, an architect in San Francisco, who pulled together 100 different models that he presents in this compendium. And we will put the link in the chat at the end of the seminar here. And it's just fabulous to page through. We were going to have you engage with this compendium during the webinar today, but our testing found that the type was just way too small for people to engage with, and people will have different size screens. So we'll invite you to look at that on your own time. And for the activity today, we have selected a set of 9 models from across the 100 that are in the compendium that really show the traditional box and arrow configurations here, the circular ones in different formats that really show iteration and the cyclic nature of the design process, and then a couple that show the converge diverge kind of shape that can be quite useful. And what we are going to be doing when I'm with students and in a physical classroom, what I do is actually hand out physical, I copy and hand out physical sections of the compendium with different sections to different groups. And I have the groups of students choose example models that resonate with them. And then they put them up on a wall, and we all as a crew go around and each group presents what models are interesting. And so the students are living with the many models and describing it themselves, and then engaging in a conversation. And so they've had a lived experience that really demonstrates that there are so many different models. That's not feasible with the time constraints and the small screens constraints that we have today. So today we're going to engage in an abbreviated version of this, just so you can get a sense of the kind of aha moments that the students have. I am asking Eileen to, we're going to put you in breakout rooms with 3 per room, and Sridhar is going to shuffle people around. If you end up with only 2, then somebody will pop in and hopefully be 3. If you end up with only 2, then just roll with it. We're used to rolling with things as teachers. And Eileen has just dropped the link to the Google slide deck. You'll be in breakout rooms accessing a Google slide deck. When you get into the Google slide deck, I'm going to go through the instructions here. You'll find a slide for your Zoom group number once you're put into the breakout groups. But if everybody could start trying to get into the participant working deck, it's really important that you get into the working deck before you get into the breakout, because once you're in the breakout, you can't access the chat in the main room. So if people can hit the link, and I can monitor over here. We're starting to see lots of people getting into the deck there. So I'll give people a moment, and then I'll go back and I'll walk through the slides that everybody has in the deck. All right, so there will be a slide that you can put questions in once we get you into the breakout group. So what you'll be doing, you'll have 8 minutes to do this task. Again, when I do this with students and they have sections and they present to each other, this can be something that can take anywhere from 20 or 30 minutes up to 50 minutes, however you want to handle the class discussions. But today we're zooming through it, literally. So as an individual, you'll find a slide with your Zoom breakout. So we go into a breakout room and it'll show you what breakout room number you're in. So take a note of that. Find the slide that has that number on it. So Eileen has pre-made slides, so you don't need to make a copy of a template. And then individually, find a model that you find compelling from the next set of slides. So I've taken those models in the slide before and just split them out across multiple slides so you can read them a little bit better. Pick one that you find compelling. Take the image and author and put that on your slide. Make a few notes about why you found that was compelling to you. And you'll have 4 minutes to do that. And then take the last 4 minutes to have a conversation, of course, introduce yourself, find out where you're from, and write down a couple of takeaways from the group. So you'll be looking at these set of slides to choose one of these models that you find compelling. This is the slide that you'll be navigating to for your own group number. So if you're group 43, you'll find Zoom group 43. And then you'll choose one of the columns, choose a model, put it in here, write why it's compelling, and then write your notes as a group at the bottom of the slide. Juliana, Eileen, and I did an example slide here. A couple of them not from the set that you have, but from the compendium itself. So I chose this model because it included context as well as users, and a growing spiral demonstrates iteration. So that's an example one. We have also a slide in the deck where you could write questions about the activity, and we'll answer the ones that we have. This is how you could communicate from the breakout group to us in the main room without having to pop up and ask us a question. If you have a question, chances are someone else does too. So this is our way of trying to help communicate with all 50 groups at the same time, or however many we're going to end up having. So hope if you haven't had a chance yet, make sure that I'll give you one more second to click the working deck. So you're in the working deck.
You want to give time for a couple of questions people might have, logistic wise?
Sure. Let's.
I mean, how do you take a picture and put it over there?
Eileen, do you want to answer that? You can do, since it's in the slide deck,
yeah.
you can do a copy paste if you're actually in the slide deck itself. If you could also use a screenshot if that works better for you, or a clip it program if that works better for you. But hopefully you can just do a copy, and if it's hard for you to do a copy and replace, you can just describe right in where it says your model choice, just write in, I've chose a spiral model.
I think that's a good idea.
Go with that.
That's a good idea, because many of them are on smartphones. Right.
Yeah, if you're on a smartphone, don't even try. Just in your model choice, say, I choose a spiral model, and say why.
That's a good suggestion.
Good question. Okay. Good question, Krishna. Glad you brought that up. Okay, so Sridhar, if you could put people into breakout rooms with 3 per. All right, and so. I'm going to look at I will be right back. Okay, how are we doing on time, Eileen?
Yeah,
Should I
we
wait
have a lot
until the
of people
rooms are
still
a
sitting in the
little?
main room. Please join the room assigned to you. Otherwise, this is going to be a waste of your time. Please, we have a lot of people still sitting in the main room. Please join the room assigned to you. Okay,
Uh-huh.
that's the whole point of this exercise, not just to sit and wait it out. Okay, be active. Join the rooms. Okay, yeah, please. I'm seeing that gradually people are going. Please join the rooms assigned to you and give it a shot. Okay, maybe it's a new experience to you. You know, there's some learning that you'll find from this process. Okay, there's still about 35 of you still sitting here, not sure what to do. Please join. 60 others have gone to the rooms and are really having fun.
Okay, I'll do a refresh on my screen here. Oop. You can hear my old 14-and-a-half-year-old dog coughing in the background.
Again, I urge all of you, the 35 of you still here, okay, who are not actively participating. This is so behave like you're active students, not your students who are not interested in what you're doing.
Okay, and who knows, you know, people might be having challenges with
Yeah,
technology.
they do, and that's what happens. And I know,
Yeah.
but I'm still trying to coax them to
right.
overcome those challenges. Some of them do have challenges technologically. But,
And yeah, I think one of the things we'll see how far we're able to get. This was
no,
the intent.
you'll get a good number of people, you know, who are active and you know, it's good.
Yeah.
Okay, I'll start the timer now.
Oh, you hadn't started the 4 minutes yet?
I started it right now, but I can go forward by 2 minutes.
Yeah, let's do 2 minutes and see where we are, Eileen. But yeah, I think well, let me know when 2 minutes is up and then we'll figure out how many more because we're and you know, this is definitely showing us that it was really good that we didn't actually do the accessing the Doubly compendium, because that would have been we had multiple iterations of, is this going to work? Like, are these activities going to work? Whoops, I don't know what I was doing.
Yes, some of them will work. I can guarantee you that, Cindy.
Yeah.
Some of the groups will come back with a lot of exciting things they've done. Yeah.
Yeah. So Eileen and Juliana, when then you're trying to pull some of what their comments are, we'll just, you know, also see what we've got there.
There's a question on slide 9 of the working deck about
Okay.
how to start the activity.
I'm all by myself in room 22, so Sridhar, could you help that? How could you please guide again how to start the activity? Okay. So see instructions on slide 2 in this deck. Look at the models. You can see how well I type. At the models on slides 3 to 6, to choose one that you resonate with. Put it on the slide for your group.
We're at 2 minutes now.
Okay, how are we looking?
I'd say about a third of participants have got like images selected, maybe a fourth.
Okay, so let's go 2 more minutes. And And Eileen and Juliana, if you could just grab a couple of the comments that are already in there, we'll have enough to talk with. Some of the groups, it looks like, are already putting some slides, some comments from like group number 14. Yeah, so we're already getting some people putting in comments. So Eileen, how about if you drop in a comment that says, if possible, start to have a conversation about what kinds of insights you fill in the whatever you were going to say, fill in the last question as a group at the bottom of the slide.
Okay,
And
I
then we'll-
broadcast the message.
Okay, cool.
We're at 4 minutes now.
Yeah, and then that includes, because I think that enough people are having problems with the technology that we'll just run with the ones that we have already seen. And the
Yeah.
whole intent was to get a flavor.
Sure. It's all a learning process. Even those who haven't completed the assignment will have learned something in the process.
Oh, yeah.
Yeah.
And people in Malaysia, it's 9 o'clock. It's 9 at night. And so, you know, we're happy that they're there.
Couple of them are in their cars driving home.
No, if you are driving right now, hang up.
No, they have drivers, they have chauffeurs.
Okay.
Many folks in India don't do self-driving. And they
Okay.
have people driving them. So yeah.
Okay. Like, that's the last thing we need.
The last thing you want is an accident while they're doing the exercise.
I would have, I would feel guilty the rest of my life. That would be a terrible thing. Okay, so what, can you drop into the breakout that will come back in 1 minute, or make 30 seconds, and so people.
30 seconds.
Yeah, do a 30-second. I'll do another refresh and see how. And then okay, I should also refresh. And Eileen and Juliana, do you have the slides? Slide 55, are there any insights from sample takeaways?
They haven't gotten to that part yet.
Okay, so why don't, but you do have some for 54?
Yeah, I'm still grabbing some.
Okay. So if we can grab them by that time, fine. If not, then I'll just roll with it. All right, so Sridhar, if you could pull people back.
Okay, I'll give it 30 seconds.
Okay, 30 seconds and they'll all be back.
Okie doke.
A lot of them use smartphones, and that's part of the problem.
Yeah.
It's very difficult to see on the small screen.
Right.
What they're supposed to do. Yeah.
Okay, so
Boost is not in the meeting.
are we back?
Yeah, we are, I mean, most of them
All
are
right.
back.
So,
Some others went to dinner.
Yeah, which is completely completely reasonable. So just to remind everybody that this exercise was to get a flavor for, wow, there's lots of different kinds of models out there, and we saw some people were able to handle it with the technology. We were relieved that we didn't at least have you access the Doublerly Compendium itself, which would have been even more difficult. But some of the responses, so Juliana and Eileen were pulling together some of your responses as you were working. The choices about why this model was compelling. Divergence and convergence allows participants to explore problems and solutions. The Meserovich model emphasizes each stage of a project will have analyze, synthesize, evaluate. Flow suggests difference between abstract and concrete. One of them is like a waterfall, moving from abstract to concrete, thinking about new ways you can grow, involving phases at different knowledges, at knowledge of design. So lots of reasons why you would choose, and the students would choose lots of different models, which is exactly what you want them to get, that different models have different affordances. And then having the sample takeaways from the group conversation. Group 31 was saying it comes naturally with convergent and divergent thinking. Group 5 was saying design from different fields is essentially the same process. Yes, there's overlap and lots to learn from other areas like architecture. Absolutely. Group 17 saying there's a large variety of options out there. So these are fabulous takeaways, and they are the exact takeaways that students have when they engage in this activity. So students say, cool to see how different fields develop different design models. Like you were just saying, architecture, interesting to compare to engineering. Interesting to discuss pros and cons of each design model and choose which to apply to our own personal process. So already in this exercise, students are relating it to their personal design. And then here's my favorite, is there an aha moment? There are other models of design other than what we've been taught all these years. So yes, design is not a recipe. Design is a process. It's flexible. There's many models. The different variations that we use with this. I've already talked about in-person assigning pages to groups. Of course, we've done the same thing then during the pandemic in a Miro board, assigning groups different sections. And if you don't have time for 20, 30, 40 minutes in class, something that you can do is just have people pull out their phones and do a flash search for design models. And then you'll see just pages and pages and pages of models of all kinds of different configurations of design processes. So here's a search I did a couple days ago on with all models, and then specifically with software engineering models. So many models, so many useful models. Let's help our students realize that. And we can also help our students realize that we can also learn from our colleagues who are artists. These are four representations from artists. Those of you living near Mumbai might recognize this sculpture at a park in Mumbai that Tata actually dedicated. And it is a representation of 3 rotations of the hand through the charka, which is just beautiful. And you can see the variation that's important in engineering modeling in this sculpture. A couple of representations of the process of life, and a 3D printed representation of a moth's flight path around a flame. So we can look to our engineering models, but we can also look to representations of process from artists to help us make the points with our students. So there we go. That was the second interactive activity, which goes better with students. And thank you everybody for being good sports and trying it out with your small screen technologies. I would give the teacher in this case, maybe we got a C+ on that, developing that exercise, maybe a B-. And we're about ready to dive into expert design behaviors. It is 7 o'clock. That means we only have 30 minutes left. So I'm going to really have to do some real-time trimming with the rest of the talk here. So to motivate the motivation for this activity, what are expert design behaviors? If you want to provide students with a lived experience so that they can understand that there are expert design behaviors, and I'll talk about what they are in a little bit, but that new designers can learn these behaviors and can, from a mindset perspective, the data actually demonstrate a nimble mindset with iteration and fluidity. And so diving right in, recalling that I got into this because I was really wanting to teach students to think about context. I did some design expertise research for a couple of decades, embarked on a quest funded by National Science Foundation to gather data from a large number of engineers doing design with various levels of expertise. They solved design problems out loud, created quantitative measures from verbal data, and then we compared processes across levels of expertise, so comparing experts and novices. So we're going into a bit of the talk, which is presentation, research presentation, so you can understand what these data actually are. There are many collaborators. So this research is a team sport, and I just wanted to make sure to acknowledge all my collaborators with this work. And the corpus of data includes data from 177 individuals solving design problems, 400 problems, about 300 of them were out loud. And the people had various levels of expertise, about 150 students, about 20 practicing experts, 4 educators and 5 domain experts. I'm going to talk about a subset of the data, and that is data from people designing a playground for a fictitious neighborhood, subject to a set of constraints like cost and timing. The data come from 26 first-year engineering students, 24 graduating seniors, and 19 practicing engineering expert designers. The individuals had up to 3 hours in a lab-based setting. They gave a think aloud protocol. So they talked aloud while they were solving the problem. We took the transcripts and we segmented them into idea units. So each unit was developed by and segmented by 2 individual coders, argued to consensus, independent coders. And then each segment was coded by 2 independent coders, comparing and arguing to consensus for the final demarcation of what code was assigned to what piece of text from the transcript. A schematic of what that looked like. These are the 3 samples of the 3 groups, first year, senior, and experts. They were in a lab. They talked out loud. We coded the transcripts. I'll describe the representation in a moment. But what's important here is to say we also took their solution and we evaluated the quality of the playground they designed because we wanted to relate the quality of the process, the attributes of the process with the quality of the product. How did we actually code the design process? Well, what we wanted to do was use the language that we were teaching engineers with. So we did a content analysis of 7 engineering design textbooks and found that they had a common language of these 10 codes that we find familiar from the design thinking codes we talked about before: defining the problem, gathering information, generating ideas, etc. And if we took these codes and put it into a node and arc model, it's this familiar one that I've been showing throughout the webinar here. So here's a representation of what the data look like. This is a timeline of how one individual who designed the playground spent time as they were doing their problem solution. So in the 3 hours, time goes from left to right here. And then the y-axis are all of the different design activities: problem definition, gather information, generate ideas, model, feasibility, evaluation, decision, and communication. And so when we're looking at the transcript, the coder came across a student saying, do you have a list of materials? Then that would be coded gather information, and a slash would be put on a line here, and you would represent all of the codes across time to come up with a timeline of how people spent time in their design processes. This next representation, I'll take a moment to describe. This is sampling from the data from first-year students and graduating seniors, first years on the left, graduating seniors on the right, with the first row being a first-year student and a graduating senior who had a low-quality playground design. With the middle row, a representative timeline from students who had a middle-quality playground design. And the bottom row are timelines from students who had a high quality playground design. So again, first year students on the left-hand column, graduating seniors on the right-hand column, low quality design at the top, middle quality design in the middle, high quality design at the bottom. And what I do with students is in the class, I have a handout so you can actually see the representation up close and have a key and really be able to see what's going on. And I ask them to find similarities and differences between the first year and graduating seniors across all 6 timelines. Then they do a think, pair, share within either as a pair or in a group, depending on the configuration. And then we have a general class discussion. This can take around 30 to 60 minutes, depending on how the discussion goes. And it's a very rich discussion. People are able to make some fabulous observations. With the constraints that we have today with time and small screens, we're just going to engage in a very abbreviated version to get a sense of the exercise. And I'll be giving you a minute to look at a couple of timelines and write your responses in chat. Try not to look at the other responses until you submit your own, but we'll just go with whatever happens here. And so again, if we were in a class or had a big screen, you would be looking at all 6 timelines. For this exercise, what we're doing is asking you to investigate the timeline from the first year student with the middle quality playground design and the graduating senior with the high quality playground design. And so here, you're looking on your screen, there are the 2 timelines. And in chat, if you could jot down what similarities and differences you see between these 2 student processes. And you'll have a minute to do that. Bye from Perth. Yes, it's 10 p.m. Oh, full screen while we look. Yeah, sorry, that was a good suggestion. All right, so if you can post what you see. Yep, sorry, that was a good suggestion on full screen, but we are past that. And so what we're seeing is, let's see, modeling part is similarity is they both use the same time frame. Yep, they spent about the same amount of time, but the distribution looks really different. Expert covers all steps in the process. Novice omits many and doesn't do much with others, right? And sort of focuses mostly on modeling. They both spend much of the time on modeling. The difference is the first year students are more engaged in modeling than the other aspects of the design. So the high quality and graduating seniors did a frequent evaluation and more communication. So really great observations that you've got here. Graduating seniors gather information more often than first year students. Absolutely, that is absolutely one of the things that happens that's super important. Thinking skills are different and they're employed, and we see them employed differently. Gather continuous improvement by getting a big picture after each iteration. So the graduating senior. So really great observations that you're seeing comparing these two timelines. When you add the rest of the data in, another thing that you can notice is the first year students with low quality timelines end up actually reading the statement, coming up with one or two ideas, reading the statement, but they're never actually able to choose something to actually run with. Most of the students first year students have some version of this second timeline here, where they do a little bit of problem scoping, understanding the problem, but they choose a solution early and then they model and don't do much iteration. But these observations that you have, that the high quality graduating senior has a robust set of interactions and fluidly going from one thing to another, gathering information throughout the process, spending a sufficient amount of time doing problem scoping, are all some of the findings that we see. So great observations that you have there. When we do the comparison across the two groups, we find that graduating seniors were significantly more likely than first year students to have higher quality designs. That was a huge relief to me that our graduating seniors actually have higher quality designs. But we also see that they make more transitions or iterations among design activities. They scope the problem more effectively by covering more categories of information, and they progress sort of further into the design process, getting to activities towards the end of the process. Students love this exercise. Engineering students love data. And so you can see, for example, a student here saying, after engaging with this exercise, super valuable, much more compelling to see real data, detail, makes me believe, instead of tuning out prescribed information. So super helpful. What a surprise to use data with engineers. When we use this with engineering students, these are, for example, we ask students, what are the most important things you learned today? And in a class of about 30 students, we see a variety of answers, but their takeaways are: you need to be broad, you need to iterate, you need to gather information, etc. Teaching with timelines variations. Sometimes we print out the timelines and have students physically sort them, which is also another sort of like physically embodied way to interact with different kinds of timelines. We can have students online do Google surveys, and I'm looking for ways to skip forward here. I'm going to skip past the when you add expert, there's papers that you could read, or I could point you to some things. You add experts again, spend more time problem solving, those kinds of things. But I'm going to skip ahead to using the timelines as a canvas to teach our students about these design expert behaviors. You can really very clearly point out in a timeline that it's super important for people to understand the problem, to diverge before you converge by doing thorough problem scoping. The observation somebody made that you gather information throughout the process, the fact that you transition and iterate during the process, and that you actually have to decide something and stick to it as well. One of the students who engaged with the exercise sketched on top of the timeline what they called an ideal project envelope, and that's a cascade shape sort of going from upper left to bottom right. it can be really useful when you're teaching alongside the abstract models. These do not replace them. We need the abstract models. But when you have an abstract model and you say you should iterate, follow the arrow, it's helpful to provide a timeline which viscerally shows a student this is what transitioning and iteration look like. We have the slide deck will be on Canvas. So many people told me that the timelines look like music, that we sonified them so you can play them if you are interested in hearing what design sounds like. And the bottom line summary from this exercise is, from these data, are that the more experienced designers have more complex processes, and that student takeaways from engaging with these data, these are reflections from last week, students who engaged with this, with these tasks last week. And you can see the sophisticated nature. This was a reflection, give us a sketch of what you learned. Here's a student who's already making the links about needing to use different models to show different kinds of elements of design, looking at converge, diverge, and that ideal project envelope, along with the Tuckman teamwork model. And then a student who's actually showing that there are many ways of progressing, and these different elements have different shapes. So we have 13 minutes left. I'm going to be moving quickly through sort of a few more ideas. I wanted to revisit that. My whole goal was to try to figure out how to teach engineering students to think broadly. This is now a global endeavor. As the globe, as we all know, we're really dealing with huge problems that we have to work together to solve. There's a focus on sustainability in engineering curricula for good reason. You can look at the UN Sustainability Goals, the US National Academy Grand Challenges, and engineers need to be part of the solution. And at the very least, we need to be designing things that don't add to the problems. So as educators, we need to be teaching our students, when we're teaching about design, that design thinking is a process, and that our students need to be engaging in that process with a nimble, broadly scoped mindset, being flexible, being reflective, seeing the full cycle, being human-centered, and really taking a broad perspective and understanding context. What are we doing on our team? We showed you 3 of many activities that we have. I'm going to briefly show you the website and then get into some what could you guys be doing. I invite you to go to our website, and we'll drop a link to that at the end of the as well. And in the website, you can access a brief description of the research, but you can also, and I'll just go over to the website here. You can also, in the app, we have developed an app where you can actually engage and create your own design timelines. You can put in your own design model. We have 5 models that we've seeded. But the app itself will generate timelines like you see on the right here. It's all developed by a team of undergrad students. And you can enter your own model. So we have 5 models like diverge, converge, and a node arrow, but you can enter your own design model. If you're doing epics, you can put the epics model in here, and you can create your own timelines either synchronously or asynchronously. And I have classes do design challenges and code their own design processes, so we can, and these are the timelines that the app develops. So you can use these in class and have robust conversations about what design processes look like in the moment. It's awfully fun. Let me know if you try out the app. I also want to point out, we developed a series of 10 exercises in a seminar we called Dear Design, where students do a design process, represent their process on a postcard every week, seen through a new lens, an interpretive lens. And after 9 weeks, they envision themselves as a future designer and create an aspirational design signature. You can see in the Dear Design tab, we have beautiful postcard representations of design processes. These are aspirational design signatures and design processes that students have sketched across a 9-week course. And so we invite you to look there. If you look at the learning materials section, you'll see the seminar, and you'll see that we have chosen 3 of the topics to talk about today, but there's a whole series of 10 learning activities put together in the seminar that you'll find there. Almost all of them are there. And there's also a couple of workshops. If you want to grab these workshops and do them with your students, please feel free. So that's what we are up to, and we invite you to look at that. And I'm going to skip ahead a bunch of slides. And what I did last week in my class was have students design a marshmallow tower, and they did coding. You don't need an app. You can do something on a physical piece of paper to do coding. So this is going to be one of the materials up on the Canvas site. And stay tuned, there will be more teaching activities on the website coming this summer. And now, where to go from here for maybe ideas of pulling some of this into your classrooms. To recap, we have engaged with various levels of success in 3 activities that we've used with students, but when we're with students and have the time in the classroom, they really gain great insights. The activities themselves are designed with these attributes based on learning principles, and the students come away with outcomes like they see themselves as designers in their everyday lives. They understand there's many models of design. They appreciate that expert designers engage in a set of behaviors that they can learn themselves, and they develop resilience and confidence in themselves as reflective designers with a nimble mindset. And this is beautiful, Juliana. In the background, while we've been doing this, Juliana took all of the courses. So we wanted to remind us all of the beautiful number of courses that we are all teaching. And so Juliana made a word cloud of all of the different courses that you're teaching. So we're trying to think, how might some of what we've talked about today show up in this great variety of courses that you engage in? So we'd like to invite you to drop in the chat. What are you most excited about from all of the things that you engaged in and that we talked about today? So what is exciting for you from this? So I'm seeing wonderful tools in the app. That's cool. So timeline chart, cool tools and graphics, the accessible activities, different design models. Yes. Use the 1st year and 4th year graphical comparisons to teach students to work towards in every course I teach, not just design courses. Woohoo! Thank you, Rich. Design models, Boomy is saying, yeah. The way I designed the PowerPoint. Say more. The app, yay. My students who developed the app would be really excited to hear that. Okay, and now moving from what are you excited about, how could you see any of the activities showing up in one of the classes that you teach? So any sort of concrete ideas? Application design models to 1st year course. Every course topic should be designed to teach. Connected flow of thoughts. Yeah, the 1st year, 4th year comparison is great for helping students develop problem solving practice. Yeah, and having them realize that these are skills that can be developed. Like it's not sort of making things concrete, so that it's possible. Lived experience, love it. PhD research is similar to this approach, absolutely. Capstone design course, that would be great. Models for software engineering and algorithm design. Connecting one course to another course, starting from first year to final course. That's cool. Yeah, having these be sort of like glue topics. I love that. Student-centric classroom, excitement and learning. Design is not only for engineering. Yeah, we tend to think it's us, right? But we're part of the whole globe, and everybody designs. A free hand to design without restricting to a semester. Yeah, things going across the whole curriculum. I think first years are scared for asking for help or communicating evidence to show that it is what engineers do. Yeah, showing, communicating and gathering information and understanding, that's what experts do. It's not just what we do as students. Visualizing the thinking processes in good design. That's absolutely fabulous. I want to be mindful of time, and we want to
we want to give time, Cindy, for Richard and Rebecca to say a few words. And
oh, okay. Yeah. So I will stop screen share, and just let me know if please, things will be in Canvas. Let me know how it goes. Check out our website for more activities that will be coming along the way. So thank you for spending your evening.
Thank you so much. Give them a big round of applause, everybody. Fantastic, amazing. Okay, so all of you know that this webinar series that we're having, this is the 5th webinar in this series, and they are named after our gurus, Richard Felder and Rebecca Brent. So I'll give them a chance to say a few words, and then Hans will wrap it up, okay? Rebecca, you want to go first? You have to unmute yourself. You have to unmute yourself, Rebecca. No? Yeah, there you go. Now you got it.
They gave me permission. I was like, I'm clicking.
Yeah.
We're just so happy to see so many of you at these webinars, and the one today, the jumping in and seeing how these wonderful ideas that Cindy has brought to us apply to your own class. And the thing that I'm taking away is just the wonderful way of involving students in thinking about all these processes. So much to take away. And so thank you so much, Cindy, and thank you so much to all of you for being here and being such great participants.
Okay. Rich, unmute yourself. There you go.
Well, basically what Rebecca said, I think this was a wonderful demonstration. And as I mentioned in my comment here, this stuff is applicable to everything all of us do, no matter what courses we teach, but giving our students the idea of, here's what you're going for. If you want to be an engineer, you want to be anything else, this is the kind of thinking that you need to do. There's a lot more than just figuring out what equation you need to plug into, but the whole idea of maybe the most important thing is not just what you're doing, but communicating what you're doing to others, bringing them in on it. And Cindy has given us a beautiful demonstration of how to do that in a way that students are likely to understand. So thank you, Cindy, and congratulations.
Thanks, Rebecca. Thanks, Rich. One quick comment I want to make, Cindy, is I keep emphasizing to everybody that these are the ways to develop communication skills, team skills, and critical thinking. Those are the top 3 of the skills the world needs from the future and graduates of the world. So Hans, I'll let you have the last word.
Thank you very much, Cindy, inspiring you and your team of students. Thank you for this very thoughtful presentation. There's a lot that I've learned. I want to learn more from you and about these particular issues. But let me just, in terms of representation of the IFES and GDC community that I have the pleasure of being responsible for, of course, working closely in partnership with Dear Krishna, and of course with Richard and Rebecca and the series per se. I just wanted to mention a couple of forthcoming activities of both communities. I just returned recently for our first time in Albania, in Tirana, bringing together the engineering community, academic community of that part of the world in Europe, in Albania. As a European, it was a tremendous learning experience and build new relationships, not only of university leaders and professors, but students. I was deeply inspired by the students that we were able to meet at that time in Tirana. I'm leaving very soon, working very closely. And after our years of the COVID, of course, our first Asian deans meeting in Hong Kong in a couple of weeks, bringing together something that we brought together the Asian deans about a little bit more than 10 years ago in Singapore, beginning to reconnect. It'll be a pleasure to be in Hong Kong very soon next month, and then also plan with Sashtek University in Shenzhen, our GDC Industry Forum coming up. I look forward to see many of you during the AACE meeting now in Baltimore in June. And we will have an IFES GDC session and so forth without going to details per se. I'm in daily contact working. I want to plant that seed to all of our friends, and because we really have an international community as seen today, to join us in Monterrey Tech, Mexico this October. We're working very closely with the leadership of that university, its 80th anniversary, to have the IFES WEAF GDC conference there this October. And please let me know if you have any questions in any way. And students, besides the professors, besides the deans, besides our corporate colleagues, the presence, engagement of the students is fundamental and becoming more and more important in all of our work that we do. I was very pleased that my dear friend and sister Karija from Malaysia, although it is 10 o'clock at night, as Cindy indicated, who's working on our 5th edition of Rising to the Top, written by women engineering leaders in Southeast Asia. She is here and we are making progress on that, and I'm very, very delighted about that. And of course, to work closely with Krishna and his team in terms of our webinar series, almost on a weekly basis, in addition to working, of course, with Rebecca and Richard. We have a lot of other topics we hope to bring all of you together. Peace be with you. Our lives have changed, are continuing to change. I look forward to be together in person with all of you soon.
Good night, good morning, good evening, whatever time you're at. Be happy, everybody.
And I want to just acknowledge Eileen and Juliana for helping design and also
Eileen and Juliana, wonderful job.
and the word cloud. So thank you, Juliana and Eileen.
Thank you.
Bye-bye.
Absolutely.
Go and take a nap now, okay?